Okay, good evening, everyone. It's nice to see the turnout. It's really good. So tonight we're going to talk about peatlands, and my name is Louise. I'm the coordinator of Stichting Boerengroep. Can everyone hear me? Yeah. Okay. Nice. Great. Boerengroep is a critical student organization connected to Wageningen University, and our aim is to connect the students with the farmers in a transition to a more inclusive and sustainable agriculture. So we organize discussions, evenings like this one, preferably live, but yeah, these days this is the only way. And we also do a lot of excursions, and we try to give peasant farmers, but also any kind of sustainable farmer, a bigger voice in the university. And this year, now we're working a lot around agriculture in the face of climate change. And that's also why we thought it would be a really good time to talk about peatlands, and also tonight, because obviously there's a lot going on, elections and Corona, but it's also still important to talk about climate change and about how to make certain places like peatlands more climate neutral. So this is still very important, I think. We have three very nice speakers tonight: Ruud Hesselink, Maarten Vermeer, and then Frankie from Peat, an organization. But before I give the word to Ruud, I wanted to kind of test everybody's knowledge about peatlands. And so I prepared a small, just like 3 questions, the poll, which I will do now. So then normally, now launch polling. Can you see?
Yeah, so okay. You should be able to see 3 questions on your screen, and go ahead and fill them in.
Yeah. Does everyone see the questions? Okay, nice. They're not too difficult, and they're quite general. Yeah, so the first one is: how much % of the global anthropogenic carbon emissions are caused by damaged peatlands? Then the second question is: how much % of the soil's carbon is stored in peatlands? And the third question is: the ecosystem of peatlands is very specific, and there are a number of species that are highly adapted to the system. But which plant is not commonly seen in peatlands? So which plant would you not expect is not specific to peatlands, at least? Those are the questions. Okay, I see the answer is rolling in. Okay. I will wait a little bit more. 22 out of 32 participants voted, but I'm not sure. Yeah. This is just a little bit to warm you guys up, and also to see how the knowledge is in the group, or if you guys already know everything, or if we still have things to say. Okay. Okay, I see that most of you have voted, so I think I will end it here. End polling. Yeah. And then I can share results, I think. Yeah. So the first question, the majority guessed correctly. It is about 5% of carbon emissions that are caused by damaged peatlands, which is still quite a lot, since only 3% of the surface in the world is covered as peatlands currently. Then how much % of the soil's carbon is stored in peatlands? About 35%. That's also correct. Yeah, 25 could have also been, but it's more. It's actually more than in the world's forests, which is quite interesting, because I feel like not as many people talk about peatlands as they do about forests, which are obviously also very important, but in perspective. Yeah. And the plant that does not belong in peatlands is indeed sea buckthorn. And 52% guessed correctly. So I think a lot of you already know a lot of things. I'm not sure if everyone knows the other two plants, but they are quite fun and very specific. Yeah, so that's nice. So I hope that you're warmed up a little bit now. Yeah, and then I would like to give the words to Ruud, who will share his presentation, and he will start with a bit of a general introduction to peatlands, and after that he will give the presentation of his research. So that will be nice. Okay.
Yes, thank you. I will shortly say something about myself. My name is Ruud Hesselink. I graduated last year in Wageningen from the study landscape architecture. And currently I work at a small landscape design firm called Odin. So last year was the last time I gave a presentation in English. So my English is still a bit rusty, but I will try my best. So let's see, an introduction to peatlands in the Netherlands. Let's start with the first slide. What is peat? So peat is basically dead plants, and normally dead plants, they decompose. But in peat soils, the water level is so high that that it can't be decomposed. So the peat soil is building up, and the ground is becoming higher. So the plant, the roots of the plants are dying, and the the plants are growing. So the soil soil is going higher up. So here we see an here we see an image of the soil. It's called a fen peatland, and this is new peat moss on the peatland. So what are peatlands? There are a lot of peatlands. You have bog peatlands, there are fen peatlands, but also swamps and marshes are peatlands. So all ecosystems where plant material doesn't decompose are called peatlands. So how does a peatland ecosystem form? It all starts with a lake where the water can be infiltrated in the ground and it can't flow away. So there is a sort of layer in the ground where the water can't, which the water can't penetrate. So then at the edges, the plants are taking over and the water is becoming smaller and smaller. And in the next stage, the water is gone completely. And this is a peatland. It is still, the water is there, but the water is now in the peat. And this type of peatland is called a fen peatland. And this is the topic where Maarten's thesis is about. And this type of peatland is fed by groundwater, but also by rainwater. So this is a more nutrient-rich ecosystem. And then the next step in the succession of this ecosystem is when there's a lot of rain and the peat keeps growing, and then a certain species of plant take over. It's called peat moss, and then you get like a big bog. And this type of ecosystem is purely fed by the rain, so it is nutrient poor. So why are peatlands important? Mainly because they are massive carbon sinks. Here it says 50% of the Earth's soil carbon, but maybe it's a bit less. But still, a very small percentage has a lot of carbon. So in the light of climate change, this is very significant, because the peatland ecosystem is the most efficient carbon sink on the planet. So instead of talking about forests, maybe we should be talking about peatlands. But I guess peatlands are not that sexy. So what about peatlands in the Netherlands? In 500 before Christ, we had a lot of peatlands. All the brown areas are peatlands. And somewhere between 500 BC and 2020, we lost a lot of peatlands. And now all the peatlands are agriculture and some nature. So what happened to all the peatlands? That's a good question. I will try to answer it. So this is an historical development of the peatlands. Back in the day, we used to live alongside the river, and there were huge peatlands. And when the population grew, we had to look for new land. So we cultivated the peatlands by digging ditches and by draining the peat, because the peat is almost all water and dead plants. So when you drain the peat, the water goes out, and the peat, the water goes out of the peat, so the peat will oxidate. That means that all bacteria and small animals, they eat away the peat, and the peat goes away. And here we see an historical development. So the peatlands were a lot higher, but when you drain the peatlands, they shrink. And we even invented the mill to drain the water from the peat into the higher water. So the most of the Netherlands was actually a lot higher than now. So how are they used? They are used as fuel, because we dug away the peat and we let it dry, and it became energy. Like you can warm your house or you can cook on it. And now the most peatlands are agriculture and some nature. Here you see, for example, a laagveengebied. It's called a fen peatland, and this is mostly grassland. And here you see an agricultural system in the raised bog landscape. And you can see here the black spots are actually still peat in the soil. So most of the soil is sand, but there are still a lot of places that are still peat. So this is a selection of landscapes in the Netherlands. As you can see, they all have one thing in common. There's water. These are the fen peatlands, the topic of Maarten's thesis, and these are the raised bog peatlands, the topic of my thesis. So the main problem about peatlands is that when you drain the peat to perform agriculture, the peat will shrink, and then it will oxidate. Like all these little creatures, they eat away the peat, and that results in CO2 emissions. So each year per hectare, there's a lot of CO2 going in the air. And not only this is a problem, but there are more problems like soil subsidence, and that means that the soil is going down, as you could see in the previous slides. And also the soil and water quality will become lower, and the biodiversity will shrink. And maybe the worst thing is that climate change amplifies this process. So it's like a positive feedback loop. So a problem of the peat oxidation is that the soil is shrinking, as you can see. This was once the level where the homes were built, and I don't know in how many times, but or in how much time, but the soil is going down, as you can see here. So the land goes down and the sea is rising. There are also problems for agriculture, like the heavy tractors. They can't access the land, or in the lower polders that are below sea level, you get saline seepage, so the water will become salty. And also there are restrictions to land use, because with these high water levels, you can't build or you can't cultivate maize or beets or something like that. You can only use it as grassland. And there are also problems for nature. Well, because the soil and water quality will go down, biodiversity will go down. You have a lot of nitrogen deposition and drought. The drought means a lot for the peat nature, because peat can survive in dry conditions. And with all the nitrogen in the air, you get that it will result in one species taking over. So here you see Molinia, it's called pijpenstrootje in Dutch, in a raised bog nature reserve. So this is not the plant that used to grow here, but it only grows here because of the nutrients, because the nutrient level is too high. And there's also an urgency to change, because we all signed the Paris Agreement, and this resulted in the Dutch Klimaatakkoord. This will reduce the CO2 levels, and we made a commitment that in 2050 we have reduced our CO2 emissions by 95%. And currently, our peatlands in the Netherlands, they emit about 2 to 3% of the CO2. So if we don't do anything, our peatlands will count for 50% of the CO2 emission that we can still emit. So there's also an urgency to change the land use on the peatlands to stop the peat oxidation. So there's quite a simple solution to this. And the solution is to keep the water levels up. But this is a conflicting interest with agriculture, because agriculture needs to have lower water levels. And lower water levels means more peat oxidation. So to stop the peat oxidations, we need to keep the water levels up to actually mimic the conditions of the peat ecosystem. So we need to help nature by creating wet agriculture, and this is called paludiculture. So we can go from climate negatives, so from peatlands emitting CO2, to climate positive, to making new peat again. So how is this done? Well, increasing water levels. So you have water buffer for dry periods. Well, this stops peat oxidation and its problems. But it can also lead to new peat forming. So in activating the carbon sink of the peatland ecosystem. Well, this can also result in new products or local production chains from the crops. Here you can see how it works. So, for instance, we have a paludiculture crop. Let's call it reed. And reed has the roots and the rhizomes in the ground, and the ground is always wet. And this is the place where the peat is formed. And this is the harvested biomass. So once a year, you harvest the biomass, and the roots produce the peat, and then the reed will grow again. One problem maybe, or yeah, I don't know if you can call it a problem, but the economic side is there is less revenue, but also less cost. So you don't need to fertilize on this ground, and you don't need pesticides. So almost no maintenance, but also maybe less money for the harvested biomass. And I can all recommend you this book. It's called PALUDICULTURE, Productive Use of, I can't read it now, Productive Use of Wet Peatlands. And it's from the Greifswald Meyer Center. And I also call this book the Bible because it was like my foundation on which I built my thesis. So I will present my thesis next, and after that Maarten will present his thesis. Maybe there are some questions already, I don't know. Louise?
There are no questions in the chats, but maybe I should...
I have a question.
Oh, okay. Yeah, go ahead.
So actually, how big is this area in the Netherlands? Like how much percentage of the farmers are currently having this interest? Is it just a little amount of the farmers, or is it like a large amount of the farmers?
Yeah, that's a good question. Maybe I can share it again. So here we see the amount of peatlands in the Netherlands. So, well, maybe 5% of land use is peatland. So yeah, there are quite a few farmers who have this problem, and especially in the Green Heart, it's called the Groene Hart.
Yeah.
So there are quite a few farmers with this problem.
Yeah. So, but it's not half, for example. It's like maybe 5% or so.
Yeah.
Maybe between 5 and 10 or something.
Yeah.
Depending
maybe.
on the intensiveness of the agriculture. Yeah. Okay,
Yes.
thanks. That gives a bit of perspective.
Okay.
Yeah, and then maybe I forgot to mention that if people have questions, then you can either, if you don't want to forget them, you can put them in the chat, or otherwise you can keep them until the end of the presentation. And I also forgot to mention that we are recording this webinar, and if so if you don't want to be in view, but normally participants aren't. It's mainly the presentation, but when you ask questions, for example, then you can be. So then you can just turn off your screen. That's just what I want to mention. Okay. Yeah, go ahead, Ruud.
Okay, so I will continue with my presentation about my thesis. So the title of my thesis is called PALUDICULTURE Landscape Machine, and it's about the regeneration of the raised bog landscape. And in my thesis, I did a case study in the Bargeveen landscape system. And so let's go back in time a little. I don't know in which time this is actually, but here you see the peatlands back in the day, and the dark brown peatlands are the raised bog peatlands. So maybe for your image, this is the north of the Netherlands, and this is a part of Germany. So the dark brown areas are raised bog landscape, and the light brown areas are fen peatlands. So actually the border between the Netherlands and Germany was one large raised bog. And this is an excerpt from an old map from 1634. And this swamp was called Boertang. And my Latin isn't that good, but it says something like desertum op paludes et aquas in accessum. So this means it is wasteland, which are inaccessible due to swamps and water. So it gives you an image of how large this area was and how wet it was. So if you then zoom in into the orange square, which is my case study, the Bargeveen area. So this is actually in the southeastern part of Drenthe. And here you see the German border. So it is on the border with Germany. And it's a really large nature area, a raised bog nature reserve of 2,100 hectares. Yeah, as you can see, it's also extremely wet. So if you then look at an raised bog ecosystem, the way it used to be, it's something like this. Like there are large cushions of peat with a certain water flow and a stream which will get rid of the water. And the way it is now is that almost all the peatlands is cultivated into agriculture, and only a small part remains. And in the Bargeveen specific, only a small part is still the way it used to be. And the rest of the parts of Bargeveen is also dug away. So the peat is dug away. There were cushions with 5, 6, 7 meters of peat. And only one small part of the area is still like this. The rest is like half a meter of peat. Or a meter. So it's a nature reserve and it's Natura 2000. So they are really busy with restoring it, and they are restoring it since 1992. As you can see, it's like a big dike, so the water won't flow from the higher point, which is the bog, to the lower point, which is actually Germany. And they do agriculture here. So this is like a few meters lower and they are keeping it dry. And here it's a few meters higher and they want to keep it wet. So they're building like a big dike here so the water won't flow from here to there. And this is another buffer zone. As you can see, these are enormous swaths of land that are used to actually grow this plant. It's called peat moss. But in only a small part of the Bargeveen area, this is actually growing. So the rest is like only layers of peat, and there's no peat moss growing there. So it's like a dead ecosystem. So yeah, here it says Bargeveen zo lek als een mandje, and to translate that in English, it's something like it's leaking like a sieve. So a lot of water is flowing from the Bargeveen into surrounding areas, but you want to restore this ecosystem. You want to keep it extremely wet, but well, that's not what's happening right now. Well, to restore such an ecosystem, you have to look to surrounding agricultural land, especially the land that has a large hydrological influence on the ecosystem and was once part of the ecosystem. So here we see an aerial photograph of the Bargeveen area and the surrounding agriculture. So as you can see, or well, as you can imagine, the water will flow from the higher point to the lower point. So this is lower ground, and it needs to be dry because of the agriculture, and this is higher ground, but it needs to be wet because of the nature. So there's a certain juxtaposition in this land use. So what you want to do is you want to change the land use in the surrounding area to create a large buffer zone. So with multiple water levels to keep the center of the raised bog wet, and to keep to improve the conditions in such a way that the ecosystem can restore itself, and so that the peat moss can grow. So my thesis is mostly about the surrounding area. So a paludiculture buffer to achieve high and stable water levels so that the ecosystem can be restored. So yeah, this is the possible solution which I explored. In my thesis, I made 3 designs. One for the area of New Schonebeek, another one in a German polder called Annaveen, and A third design is a design on a larger scale. So on a scale that was once the large raised bog area. So also with nature reserves in Germany. But because of the time, I will only talk about one design here in New Schonebek. So I designed a paludiculture system for this landscape. Let's see, for your image, this is the Bargeveen area, and it's a lot higher than the surrounding land. And the water system will flow from here into the stream valley with cattail. And this is the stream valley, as you can see. It's like the border. The stream is the border. So it will flow from right to left. And in this system, I designed with 3 crops, with willow, reed, and with cattail. Willow on the grounds with lower water levels, and reed on the grounds with a more fluctuating water level, because reed can also be permanently on the water, and cattail in the stream valley. So this is where also the most nutrients are, in the stream valley. And cattail is the most promising crop. So this is how the landscape will look like. Here you have the Bargeveen area with large buffer zones to keep the water levels stable in the raised bog. And then you have large fields of willow. And here you have a perpendicular dike, because the water levels or the ditch system is like this. And here you have perpendicular dikes to keep the water level high in this area. So actually, it's just another water buffer to keep the water levels high. And then you have the farms here. These are all existing farms. And here's the dike with the road. And in the stream valley, there are large fields of cattail, like this. So this is how it can look like. Large fields of reed with a high biodiversity, and also they also harvest the reeds to sell it. So this can be you can harvest the biomass. You can harvest the reed, for instance, for the thatching of roofs, or you can harvest the cattail for isolation. I also explored a possible regional production chain. So when you harvest the willow and harvest the reed, you can make a sort of pulp from it, cardboard. And with the cardboard, you can make a wickle house. So yeah, you have a large roll of cardboard, and you can wickle a house like this, and you can put it back again in the Bargeveen area. So with harvesting products from the Bargeveen area, you can make a product which you can then place into the area, and which so you stimulate the local economy with products from the land. Yeah, so that's about that. But for the peat moss to grow, there's another problem. So this paludiculture system is purely intended to achieve high and stable water levels for the nature to grow. But there's another problem. There are too much nutrients in the water. That's because there are a lot of birds in the water, and the birds, they poo in the water. So the water will become very, very nutrient rich. And also there's a lot of atmospheric deposition of nitrogen. So the water, which used to be very poor in nutrients, is actually very rich in nutrients. So we need to have a way to make the water poor again in nutrients. So the nature has a solution for this. It's called the Moorausbruch, and it's a German word. I couldn't find an English word because there is none. And it's called, it's actually a rapid discharge of a great excess of nutrients. And Kaspari called it the self-cleaning capability of the raising bog. So what happens in the raised bog ecosystem is between these peat cushions, there is stagnating water. And these peat cushions, they grow and grow and grow, so they become higher. So the water will become deeper, and there will be such an enormous amount of water in this pocket that every once in a while, it will burst through the peat cushions and the water will flow out. So that means that the bog will become drier and other species will grow. So it's like a natural succession in the raised bog ecosystem. So I also found a example of such a thing. This is a raised bog in Latvia, and it's pretty much an intact raised bog. So the whole ecosystem is intact. And here you see such a lake. And as you can see, this lake has also burst out, because you can see here patterns that the lake is leaking water. So I thought, why not use this natural dynamic component of the raised bog ecosystem in my paludiculture system. So I will try to explain it in these diagrams. If you can imagine, this is the Bargeveen area with a lot of water, and buffer zones with also a lot of water. And this water needs to be nutrient poor, but it isn't nutrient poor because of the nitrogen and because of the goose. So there are too much nutrients here, and you have the cattail fields in the stream valley. So why not connect these two? Well, the problem is too much nutrients in the raised bog, which leads into a negative feedback loop. The result is that peat moss won't grow here. So why not simulate a Moorausbruch and let the water flow from the raised bog in like once every 2-3 years, let it flow from the raised bog into the stream valley, and then use the nutrients, the nutrient-rich water in the cattail fields. And the cattail will take up the nutrients, and they will grow faster. There's more revenue, and then again the raised bog can fill up with rainwater again, and the productivity, the productivity of the peat moss will increase. So it's like a win-win. And then it becomes something like this. Here we see the stream valley with large cattail fields. So that's about it.
Thank you, Ruud. That was very interesting. We have some questions now already.
Okay.
First from Frankie, once a peatland is dead, can it come back to life? Yeah, maybe we can start with that one.
That's a very difficult question, because I've read a lot in the hydrology of peatlands, and basically when the peatland is dried out, when peat is once dried out, it cannot absorb water. So it's very difficult to return these dead peatlands into life again. So yeah, that's the simple answer.
Okay, maybe for now we can keep it at that then. Then there is a question from Inigo. It was mentioned in the introduction about the positive effects of paludiculture on peatlands because fertilizers are not needed. carbon is kept in the soil as it doesn't leave as CO2, but what happens with the other nutrients, nitrogen and phosphorus? So if you keep extracting crops from it.
Yeah.
Then maybe
So
at some point.
yeah, in Dutch it's called uitmijnen because the soil is already really full of nutrients from the agriculture, because farmers, they spread a lot of nutrients in the soil. So like for instance, the amount of phosphorus in the ground, it's like enough for 30 or 40 years of paludiculture crops. And one thing I left out in this paludiculture system is that you can also have a succession. So once when reed or cattail has extracted most of the nutrients from the soil, then you can plant another crop, like maybe a crop that can grow on a nutrient poor soil. So yeah, you basically want to have soils that are nutrient poor. So these crops are a way of extracting the nutrients from the soil.
Yeah. Okay. Thank you. That was pretty clear. Then a question from Esther. Did you also look at the effects on other greenhouse gases when raising water levels? Yeah, CH4 and N2O.
Yeah, that's a difficult one, because you also have you also in a natural ecosystem you also have greenhouse gas emissions. It's called lachgas in Dutch, methane, I think. So the net balance is that the net balance is that a peatland ecosystem takes up CO2 because it's a carbon sink. But you have also small amounts because of the fluctuating water levels. You have small amounts of methane coming free, but so that's a really strong greenhouse gas. But I think when you farm peat, there's always a net carbon sink.
Okay, thank you. We have 2 more questions, and I think then we should go on to the next one. Do you think the system can also be a solution to store or maintain water and use, and use the Moeraasbrug to store for the stored water, I guess?
Yes.
Yeah.
You basically, in this ecosystem or in this system as a whole, you want to store as much water as you can. So also here for the cattail fields, you see large water buffers. And you need a sort of system to get the nutrients to the cattail. So as you see here, you see really small ditches. And it's like, in Dutch, it's called a vloeiveld. So you want to get the water. You want to get the water really in there. So you don't want to flush the water in and out, but you want to really keep the water in there and get the water to the cattail. So and also the reed fields, they can also function as a water buffer, because reed can also grow when it's underwater. So yeah.
So it's a whole water management system in itself.
Yes.
Yeah. Okay, and then the last question is about your choice of crops. I heard that cranberries are also a possible crop for paludiculture. Why haven't you chosen to include cranberry?
Ooh, yeah, that's a good question. I really have no answer to that, because I've looked. Maybe I can show you. Or not. Yes, it's a bit slow. Anyway, I used a model for selecting the crops. Yeah, it's called, so you have a lot of potential crops for paludiculture, but you can look at different aspects, like can it handle water levels that you want? Is it the right soil type? How do they react to nutrients? For instance, peat moss. You can also cultivate peat moss as a crop, but peat moss cannot grow in a nutrient-rich environment. But you can also look at the economical point of view, and also about the nature point of view, because maybe what I neglected maybe in my story is that reed and cattail are very invasive species. So that's not really good for nature, because But you can depending on your perspective, you can choose a lot of crops. So I have no real answer for why I chose the one and not the other.
Yeah. So it's also just a question of what you prioritize, I guess.
Yes.
Because I think cranberries are very economically viable, but then on the other questions, I'm not really sure. So it's I think you can make many different systems, which is also very cool. Okay, thank you so much, Ruud. I think that was a very good introduction and first presentation. I found it very interesting. And now I would like to give the word to Maarten Vermeer, who was we studied together with you, Ruud, I think. And he's going to talk about the fen peatlands and making them carbon neutral. The peat meadow landscape. Yeah, okay. You have the word, Maarten.
Maybe you're on mute, Maarten. I don't know.
Now I'm not muted anymore. Yes. Hi. Thanks for the word, and thanks also for my introduction, Ruud. I shared my presentation, and indeed I'm going to tell you more about the peat meadow landscape, and especially in the western part of Utrecht, and to make it back in balance. Because as we heard in the introduction, the peat meadow landscape is not in balance anymore. If we talk about CO2 emission and CO2 sequestration. My route was in the eastern part of the Netherlands, and my focus is on the western part of the Netherlands. So between the city of Amsterdam and the city of Utrecht, and this is part of the Green Heart. And this is better. Now you don't now see on my whole screen. This is the peat meadow landscape as part of the Green Heart. So the light green is the peat meadow landscape. And what's going on? What we already thought, we have a climate issue in the Netherlands or in the world. And also in the Paris Agreement and in the Dutch Climate Agreement, there are statements that we also have to decrease the amount of CO2 which is erased by peat. But how much is it then? And if you compare it with a Dutch family with 2 kids, then it emits almost 41 tons CO2 of CO2 equivalent. And if you compare it with peatland which is farmed, then it's almost 74 CO2 equivalent. So 1 hectare of peat emits more than in a year than a family does. And on the left, you also see where that the family spends his CO2 budget on. So it's also important. So this is a little bit where we talk about, and you see so that the amount of CO2 which is emitted by peatlands is quite big. So this is how we see the Dutch peat meadow landscape as a nice green environment, but maybe we should look like this. Like it's a more an industrial landscape which emits a lot of CO2, which is maybe not as green as we think it is. So I think it's also nice that we have are together this evening, so we can contribute to the debate and also debate together about the opportunities if we switch from land use and to make a more low carbon society. In the focus was on the western part of Utrecht, but the drain peat is of course not the only part which is emitting CO2. So if you compare it to the other things which are in the region, like the energy use of houses, the energy use of traffic, so the gasoline, then we still see that the biocarbon emissions are quite big in comparison with the human-centered, economy-based centered carbon emissions, and that the CO2 of the sequestration is really small if you compare it to the carbon emissions. So the carbon emissions and the carbon sequestration in these three municipalities is out of balance, and grain peat is also contributing to that. Yes, out of balance. And this is not only about, in the climate agreement is about how can we generate more sustainable energy, but also on how can we have less emissions from CO2 from peat. So we also have to combine that and see those tasks and also assignments not as separate, but think along so that we can have better end results. So what is the potential of wind? The most left picture, heat, the second one, biomass and solar in this area. So could this area also contribute to the energy problem which we are facing now, or not problem, energy transition, which we are currently in? Oh. But how does this land became from also what Ruud showed, from a peat landscape to really emitting landscape, from a carbon sequestration landscape to a carbon emitting landscape? If you see around the year 1000, you see the circle, and this is where Meidrecht and Vinkeveen are, and this was also a raised bog landscape. So what also Ruud is shown in his presentation, this was a raised bog, and then the green is peat forest. So this is more fen. This is a forest, and this is hoogveen, so a raised bog. But people start to excavate this landscape. So this is around 1600, and you see also the radio excavations which took place. And a lot of ditches were digged so that the water could be flown out of the landscape, so the landscape could be used for agriculture. Because it was so low, there also need mills. So it was also an energy landscape, and the land was used to dig for the peat, to burn it in the ovens. And also, therefore, lakes existed because so many soil was excavated. And of course, the Dutch turned the water back into land so that they could use it for agriculture purposes again. And now we have a landscape which is highly urbanized, but still emits a lot of CO2, and is not more the CO2 sequestration landscape which was in the year 1000. So how could we learn also from that landscape so that we can get more in balance and have more sequestration than we have now? This image shows that in this area, the amount of CO2 which is emitted because of drainage and burning of peat is a lot more than the total Dutch CO2 emissions in 2017. So the 2000 megatons of CO2 is of course in a total different time frame. So from the start of the excavations till now, and the total Dutch emissions is 1 year. So the time frame is different. But you see that still a lot of CO2 is emitted because of drainage and burning. And if we want to have less CO2 emitted by the soil, which kind of land use can we have? And this graph shows greenhouse gas emission site types. So for each different land use, there is also a different amount of CO2 which is emitted. And on the left, you see for agriculture, So that's the most. And on the right, you see forest. And also cranberry is still quite emitting, and cattail is also emitting, but more or less than the grasslands. And it's also about the story that somebody asked, like, if we raise the water level, then still methane is coming free. And this, so that the emissions of methane increases and of CO2 decreases, but methane is a stronger greenhouse gas. This is also empirical research, and it's really difficult to measure the greenhouse gases which are emitted and sequestrated for peat. So also researchers are really troubling with how to measure the right amount. So this is from empirical research, but it's not that this is the truth, because it's also difficult. There are different methods, and each method has its own pros and cons. So with this, what I showed is the greenhouse gas emission types. We could have building blocks to create a landscape which also sequestrates CO2 and has less soil subsidence. So that could be cranberry, cattail, sphagnum, forest, azolla, that's also used for peat, cattle, reed, but also more intensive agriculture or grasslands. And to research those options, 4 scenarios, I made 4 scenarios. And the first one is agriculture production for the world. And the other one is nature. So that is a top-down, so it's large scale and based on new business cases. And more bottom-up is a more fragmented landscape. It's all still based on new business cases. And on the left, you have agriculture production for the world, it's more top-down. And then also global and local agriculture production. And each scenario has different land use, So if you think about the large-scale agriculture production, you could think that also submerged drainage will be used. And submerged drainage is that the land is drained, of that there are how do you say, tubes are in the soil, so the water level could be controlled better. So in dry summer periods, water could be could flow into the soil, so the soil doesn't oxidate, and the water level is a bit raised, but is still applicable for agriculture. So this is one thing that farmers really like, because they can still be a farmer, and soil subsidence decreases. But there are also a lot of comments and questions if this method really works. Also, you can think about the more nature, so swamp forest. So everything becomes a nature area, and it becomes a recreational area for the cities of Amsterdam and Utrecht. And the more combination of agriculture with submerged drainage and more extensive agriculture, or a more fragmented landscape where a lot of also new ways of polyculture are part of the landscape, and so the total landscape experience will change. This is a bit a complicated image, but it shows the CO2 emissions in CO2 emissions of each scenario, and then for each scenario, the left one is the less positive perspective. So because it's a range of CO2 emissions, so you only see that nature scenario will get a positive balance on the most positive bar. And these scenarios help me to also make design how it could be more back and balance for both land use as energy. So the concept is that there's still place for dairy farming on the plots which emit less CO2 because they have a clay top of clay, and that other lands are used for forest, fen, wheat and cattle, and also energy production. So you still have an open landscape on some places, but also a forest which sequestrates a lot of carbon. And also that the timber and biomass from the forest could be used to build new houses, as also Ruud showed in his images. So this is then could be the design of a new landscape, which is not a peat meadow landscape anymore, but a forest. And this could be then the fen, and the plots could turn into forest plots. And this shows that still a view on the church towers, which is now seen from over the polder, could be if you have a smart design. And the landscape could develop from top, so from the current peat meadow landscape into a forest, with also different types of forests with different water levels. And this is then how a forest from a peat meadow landscape into a forest, diverse forest with different types of trees, and from a new recreational landscape for the cities. How the forest could look like if you walk through it. And now if you cycle through it, then you have a more forest experience. Of course, it's a totally different experience than the experience is now, because now it's open peat meadow landscape. And also the biodiversity will change, because you don't have in the forest, of course, no meadow birds anymore. So also a change of biodiversity will be there. So that's also, of course, a dilemma which will happen. So in this design, we go from a landscape which emits a lot more CO2 than it sequestrates, from a landscape which is more in balance. And on the right, you see the energy used and which is produced in the area. And also a discussion point I want to share with you is that we maybe have to change the name of the peat meadow landscape to further the debate, because in the name it is that it's a meadow, and the meadow, because of the meadow its agricultural use, the peat is drained, and therefore there is CO2 emitted. So because it's like a paradox, because we have those cultural historic landscape, it also causes that it will disappear in the future. Yes, thanks for your attention.
Yeah, thank you so much. It looks so beautiful. I would love to cycle through there and then to indeed call it by a different name. We also have some questions for you. First question was, where should we focus our efforts on the most, on restoring destroyed peatlands or on creating new ones, thus converting agricultural systems which were never peatlands into peatlands? Yeah, that's a question from Eduardo. But
yeah, so I don't know, I don't understand totally the question, because converting agricultural systems which were never peatlands into peatlands it's not the case. In the presentation of mine, it's about peatlands, and I think also in Ruud's presentation, but also about the very former peatlands. So I don't totally understand the question.
Can I maybe something that we didn't speak about so far was the fact that peatlands form over often thousands of years. So the process of forming a peatland can take up to 10,000, well, yeah, sometimes 10,000 years, or maybe even more sometimes. So the idea of forming a peatland is a bit like not in human timescales, really.
Does Eduardo want to respond or explain the question, or
That's clear.
clear? Okay, perfect. Okay, and then the next question from Janina: is there an effect of roads in this kind of area? So in your design, and I guess the emissions from traffic then.
Is there an effect of roads in this kind of area? I don't. Is there an effect of roads? Sorry, I don't understand the question totally about.
For water management.
Or for the management?
For water management, apparently. Okay, Anina, do you want to explain your question?
Yeah, sorry.
Okay.
I mean, because it's like a water management system where you have like flooding and that kind of stuff. Like if there's farms in there and has to be transport, like does that affect the water flows of the area? Or would it be possible to have such a landscape if there's roads everywhere?
Yeah, of course in the past a lot of the transport was over water and not over roads. So roads are also things which happens in only the last century, in the former century, in the 20th century. And before that there was a lot of transport on boats. So some lands were not even accessible by roads. But because it's not efficient enough, we made roads over there. So now we manage roads with water management systems, but of course we can also turn it back.
And also maybe the roads are always higher, so the roads are always like 1 meter or 2 meters higher than the land. So I don't think that there are going to be a lot of problems when you flood the land with water, because the roads are always 1-2 meters higher.
Okay, thank you. And then there are two questions that are a bit related. Thomas asks, have you interviewed local stakeholders? What do you think their views will be on the nature scenario? And that's also what I wondered about. Yeah, if you also presented your model to the farmers in the area. And then the other question is, do you see a future for conventional dairy farming in Het Groene Hart, which is a bit more specific, but yeah.
I see a future for dairy farming in the Groene Hart. I don't know if it should be conventional, but I think dairy farming should be there. I think farmers are really important to keep our cultural landscape alive. Of course so I think yes, it's important, and I think they should stay there. Did you interview local stakeholders? No, I didn't interview any local stakeholders. I had conversations with the VIC, that's Expertise Centrum on Peat in Zegveld, in Den Haag. And they also do a lot of experiments. And of course, I can imagine that the farmers don't like it when you turn it all into nature, because I know more farmers which also live in peat area, and not especially in that one. And also I talked to that persons, and they were not really enthusiastic. So no, but I didn't interview the local stakeholders.
Yeah, would be a good future research also to do more like a social examination of what is possible.
Yeah, there are also the different companies did research by design, research on the Groene Hart, Flux, Sand & Co, and Fabrications, and also with the advisor of the province of Utrecht, Paul Ronke. They do a lot of research on peat, and also how farmers could have a new business case in that. And so I think there's a lot of going on in the peat area, and also I think there's still more and more attention to peat, and that the problem is more alive than a few years ago.
Yeah, that's good news.
Can I add something as well, just quickly? I spoke to a guy who is on one of the Dutch water boards. He's called Neil de Jong, and he's currently involved in this process of like doing some kind of research on whether paludiculture would be viable in certain areas of the Netherlands, because the Dutch government have now put in a big scheme to try and implement this. And he said that there's actually like very like not so negative, like actually people are quite positive about, at least in the research phase. So I mean, obviously he said like there's a big difference between in the research phase when you're like asking everyone, like getting everyone on the table and just trying out ideas, than really saying, okay, now we're going to do this. But I thought that was at least some kind of good sign.
Yeah. Yeah, I think maybe there's a feeling of that something has to change somehow, and that makes people more open. Okay, Maarten, I have one last question for you before I think we should move on to the next parts. Do you have an idea how much it costs to keep the water pumped out of these areas so that farmers can continue to make a small profit per hectare by farming extensively? Do you know what?
I don't know the amount out of my head, but I know that the PBL, so the Dutch bureau which also calculates the Farm Bureau van de Leefomgeving, who did a research on the costs, and they were extremely high. So please check that report.
Okay, thank you. Yeah, Astrid also had one more question, but maybe you can also answer in the chat if you want to, because I think we should go on to the last talk by Frankie from Repeats. Yeah, Frankie, the floor is yours.
Oh, Frankie, you're on mute.
You're on mute.
Okay. Okay, now can you hear me now? Okay, cool. I was just giving a shout out to the other repeat members that are on the call as well. So I'm gonna quickly play a 1-2 minute video just to introduce repeat. Oh, okay. Gonna work.
So, what's repeat?
Well, we're a youth-led collective co-creating a peatland paradigm shift.
And what does that mean? And anyway, what is peat?
Okay, let's start at the beginning with the Peat 101. Peatlands, also known as bogs, mires, moors and fens, are composed of a mass of partially decomposed plant matter, peat. The plant matter is suspended in its path towards decomposition by a lack of oxygen and the acidity of the stagnant surrounding water.
Oh, so you mean the plants kind of get pickled in the water?
Well, something like that. Then the not quite decomposed plant material accumulates gradually over thousands of years and creates a peatland.
Oh, I see. Yeah, I think I've been to one before when I was little. Are they quite common?
Well, they're not too common. They only take up 3% of the world's land surface. But did you know that despite this, peatlands are the largest terrestrial carbon store on Earth? They store twice the amount of carbon as all the forests.
Wow, but what exactly is a peatland paradigm shift?
Well, put simply, a peatland paradigm shift is the shift in perception that happens when you go from not valuing peatlands to valuing them. Because when you appreciate peatlands, you also learn how to appreciate the memories of deep time, space, Earth systems, and each other.
Oh yeah, haven't lots of bog bodies been found in peat and they were really well preserved?
Yeah, that's right. So part of the peatland paradigm shift is valuing the many gifts that healthy peatlands bring to the world. These include a stable climate system, reduced flooding, reduced fires, decreased saltwater intrusion, the prevention of drainage-related subsidence, and increased biodiversity. You can even find lots of weird and wonderful flora and fauna, like the insect-eating sundew. Understanding the gravity of what the world would look like without them is also part of the peatland paradigm shift.
Wow, peatlands seem to be really important for the planet. I had no idea. So tell me a little bit more about repeat then. How are you going to make this peatland paradigm shift happen?
Well, one thing that we do is talk to people like you who don't really know that much about peatlands and make them aware of the threats that peatlands face today, as well as their importance. We like to use creative modes of communicating because peatlands get our imaginations spinning. Another thing we do is connect different types of people who would not normally get together. Let's say an archaeologist and a policymaker, or a poet and a biologist, or all four.
But who exactly is repeat then?
Well, we're a collective of about 20 people, mostly under 25s, as well as some youthful over 25s, who work in 6 different working groups. As a collective, we strive to be non-hierarchical and respect different people's ebbs and flows of their precious time and energy resources. As a group, one of our main philosophies is the belief in the process, not just the outcome, which is exciting because that means we're always learning along the way.
Okay. Oh no.
So, what's repeat?
Sorry.
Well, we're a youth-led collective.
Okay.
Nice video.
How do I go back onto? Wait. Sorry. For some reason, like. Wait. Okay. Now I've got it again. Screen share. Share. No, wait. Is that right? Can you see the presentation?
Yeah, we can.
Okay.
Yeah, now it's full screen.
Okay, so yeah, I had to listening to your own voice for 1 minute is not the nicest, but anyway. So a little bit of a history of when we formed, why we formed. Most of us, or myself predominantly, had never even really come across the idea of a peat or what is a peatland about a year ago. So it was a steep learning curve. Essentially, a few of us found ourselves on a peatland excursion pretty randomly. And it was with a peat scientist called Jan Peters, perfect name. He basically just told us very simple facts, like some of the things that we've been talking about today, like the crazy amounts of emissions that get released from drained peatlands and all the different side effects of what happens when you drain them. And we were just blown away by the scale of the issue and like how important it was, and also the lack of awareness. The group that we were in, there was about 3 people, like, I don't know, a handful of people that were like, yeah, I know about the issue of peatlands. So we were like, okay, we have to do something about this. How do you make something that is for hundreds of years, for generations of culture, been like kind of put into the category of a wasteland? How do you make that interesting? How do you make that important and like spotlit? So that's where we started, and this was one of the images that we were shown right at the beginning, and this basically shows the distribution of peatlands around the world and the different levels of CO2 emissions. And so Europe is actually the second largest emitter of peatlands in the world. First is Indonesia. So it's like a really big issue, and Europe has been draining peatlands for centuries. So and then these are some nice ecosystem services, because we've spoken about most of them already, so I'm going to skip this one. And this is where the last map is from, which is a really good resource if you want to find out more information. You can type in smoke on water. And yeah, so basically we were just like, okay, we need to do something about this really big issue. So we formed this group, and we're now a foundation based in Amsterdam, which we renamed the Floating Peatland City in the Amsterdam Alternative magazine. We're volunteer run, and we now have an international member base. So this was our first project that we did back in May, and it was kind of a crazy project. We had a whole 24 hours of peat inspired talks, and we had people from all different disciplines. So we had archaeologists, poets, musicians, scientists, farmers, you name it. There was everyone from every corner, like all the peat nerds were there. And we even created like this field notebook. As you can see, the drawings in the bottom were every single session we illustrated, and it was just a crazy 24 hours really. We were all very delirious by the end of it, but we had a lot of people that engaged with it, and even people that had never even heard about peatlands before. So it was really exciting. And then we launched a petition, so that was directed at the Dutch government, and that was surrounding the use of peat in horticulture soils, because a lot of the peat, a lot of the agriculture in the Netherlands is grown on peat soils, and a lot of it is imported from Eastern Europe, among other countries. So this was a petition that we launched, along with a crowd action, which we didn't actually get everyone, which was a bit of a shame, but hey, you can't get everything in life. And then the last big project that we've been working on for the past couple months was the Peat Anthology EU edition. So recently, the decision of the next cap was voted on by the members of European Parliament, and basically this is a policy that is 40% of all EU funding goes towards this common agricultural policy. So it's a massive fund, and up until I mean, potentially when this gets passed, it's still going to be the case that farmers will get subsidized for drainage-based agriculture, but they won't get funded for example, paludiculture, because it's not necessarily recognized as a crop. And this was like one of the first facts that we found on a excursion to the peatland right at the beginning, and we just thought it was like so, you know, when things are just like, this can't be right, this is just totally illogical. That the EU that tries to be all green and tries to be, you know, being the leading green blah blah blah, is completely funding these emissions in a crazy way. So we created this peat anthology, and this peat anthology was is a collection of different forms of expression. So you have poems, you have images, you have letters, you have anecdotes, all sorts of things. And these are all kind of directly addressing the MEPs and making them think about the value of peatlands in a much more poetic and a much more like a deeper sense than, for example, the position paper that was also published by a lot of different nature organizations, which was a lot more like the facts. So this kind of went alongside that. And yeah, the decision of the Common Agriculture is still ongoing, because the final decision hasn't yet been made. And we were all very mortified to see that this latest decision that the members of European Parliament voted on is not taking climate into account, not taking ecology into account, not taking the small farmers into account. And so there was actually a big movement of Fridays for Future to kind of say, with like the hashtag withdraw this cap. So you can also follow that because it was very under documented also in the media. Whereas, for example, everyone I speak to heard about the fact that the EU is going to take away the word, like the word veggie burger. Like, you're not going to be able to say veggie burger anymore. You're going to have to say veggie patty or whatever. And no one heard about the fact that the EU was then going to vote on this fund that would be like direct, like essentially changing the history of everything. Well, history of everything, but like yeah, essentially making a very massive impact. 40% of all EU funding going to these agricultural practices that, if they're not sustainable, and it lasts for 7 years. So yeah. Anyway, so it was underdocumented. So there's still a moment of pressuring. So if anyone wants to do some tweeting or whatever, or some letter writing, then get involved.
Maybe add something to that.
Yeah.
Actually, with Repeat, we just started a collaboration with Fridays for Future, because they had this Withdraw the Cap campaign, and we did our peat anthology. And of course, like, peat was the initial reason for us to be interested in putting some pressure on the cap and getting in touch with MEPs. But it's a much larger story of big, powerful lobby groups having the final say in what happens with agricultural policy and taxpayers' money, while the stakeholders are left empty-handed. So we're now gonna probably work on a people's cap, a counter cap type of thing, where we want to centralize a transparent process and stakeholders' interest in a just transition and an agricultural policy. So if anyone is interested in working with us on this project, it's only just starting out. So do send me a message if you'd like to get involved with this, because we can really use any extra capacity at this point.
Yes. Nice. Thanks, Elaine. And then the last thing I'm going to mention is the fact that we're going to do this. We're launching a crowdfunder in the next week. And this is these 4 images on the left are from the field notebook from Peat Fest. So they're just a collection of images that talk about or that like represent each session. And then the image on the right is a illustration, which is a sketch for our children's book that we're making, which is all about a character called Ruru, who essentially goes through time as they interact with the peatland. And it's going to be also part of a larger project that we're going to start working with school children on an educational program. So yeah, this is all to say that peatlands can be fun and can be exciting, and there's lots of layers, metaphorically and physically, to a peatland. And here are our social media links, so if you want to look us up. And yeah, that's basically my presentation.
Wow, thank you so much, Frankie. I think that Repeat really makes I mean, in the beginning, Ruud said that forests were more sexy than peatlands, but I think that Repeat is doing a lot to make it the other way around. And I think it would also be very nice for Boelgroep to participate with your people's cap and all of these things. Yeah, and so the thing that we can do now is sign your petition still of Repeat and join activities.
Yeah, you can. Yeah, we can always use signatures on the I can send the link of the petition. But I would say the cap thing is definitely, if you want to get involved, then we're going to go all out on sabotaging this cap.
Great.
Or at least making people aware that it's happening, you know, like the thing, like the worst part about it is that nobody even knows, you know.
Yeah.
And it's such a big decision that is being made without anyone conscious of it.
Yeah, exactly.
Like one of the things that, like, when we in our next project, when we're going to do this educational program for kids, we're going to work with 7 to 11-year-olds because for a number of reasons, but also it's kind of like quite symbolic that when they, like, when we're going to engage them at the level of once they, in 7 years' time, they're going to be legally allowed to vote. And that's kind of the length of this cap. And so it's always like very important to also make it so tangible of like, this is 7 years of a young person's life is a long time, and they are completely unable to like have any power, or I mean, obviously have their power in different ways, but
yeah, and it's also just a very long time in terms of mitigating climate change, because I was also very surprised by this voting, because the EU says that they want to be climate neutral by 2050, but how are you going to do that by only very slowly transitioning agriculture, if at all? But that's definitely very interesting. Okay, but are there any other questions from other people? Is there a deadline for sabotaging the CAP? Yeah, when is the final voting, or when is the? Because
maybe I can answer this. Because we talked a little bit about it just yesterday. It's a bit complicated because the EU structure it's got like a couple of different organs, and then some decisions are transparent, some are not, based on like who's involved and what countries, like representatives from countries being involved in the decision, but then it shouldn't be visible what individual countries are sort of saying and voting for within a certain decision. So basically what happened is, I think the Commission made a proposal for the CAP. It went to the European Parliament, who voted for this proposal, which is a horrendous backroom, big agro pesticide influenced proposal. Now it's up to the European Commission to turn this into law, but they still have the power to withdraw the entire CAP proposal. And there's negotiations happening from now till March probably, which are not transparent. But Frans Timmermans, part of the European Commission, has the mandate to honor the Green Deal that has been basically taken up as a goal for the EU as a whole. And this CAP proposal is directly against the Green Deal goals. So this is a quite interesting part of all of this. But basically there's this intransparent period of meetings between now and March, during which we want to keep the pressure on and show that we're not letting go of this, and that we're watching them, and we really want this CAP to be withdrawn. But it's all a bit vague, and it depends a lot on what's happening in these meetings, and we don't quite know.
Yeah, it's always a bit unclear because it's so big and far away. Okay, I think we have one more question to end with, because we're already a little bit over time, but it's okay. You talk about valuing the peatlands and its ecosystem services. Is a possible solution to set these ecosystem services of peatlands to monetary value? That's a good question.
If I'm answering this, I would say that like true value, like what we try to do is get this very like holistic kind of valuing, which comes a lot more from a sense of like love and care and curiosity, and something different to maybe like putting a monetary value. Maybe somebody else would see that as like the thing that would spark their sort of deep value for something. Could be, but personally I would prefer that somebody would value it for a bunch of other reasons that aren't money. But that's just me.
Yeah. Does anyone want to respond to this? Or maybe Ruud, you yourself, you want to say what you think?
Mhm.
Yeah, maybe, because in the European Union, we also have this trade system between CO2 rights. So if we set maybe the ecosystem services of, for instance, a raised bog to monetary value, it can be that such a nature reserve like a peatland has like a stronger basis for its existence. So if we set these ecosystem services to money, we can, I think the position of these peatlands will become stronger.
Just a quick note from Beth, who's also part of Repeat. There was a woman called Catherine Farrell who was also part of the peat anthology that we did. And she's really talking about monetizing or like making kind of this into a kind of economic framework. So maybe you can also look up Catherine Farrell. I can send you a link.
Yeah.
Yes. Okay. Thanks.
Nice.
Okay, Beth sent the link. So.
Okay. Yeah, thank you so much. I think, putting monetary value to ecosystem services is a big discussion in all kinds of natural systems. So that's definitely something that we can't solve tonight, as are many other questions, but I think we had a really good evening. Maybe it was a lot of information in just 1.5 hours, but it's also, just remember that you can rewatch the whole webinar if you would want to. And I think it's very nice to also end with some things that can change, that we can do to kind of put certain models, like for example what Ruud and Maarten propose, into action and kind of make a transition happen, which has to start with a change of mindset, of course, paradigm shift. So I want to thank all three of you very much for speaking, and everyone for participating. One of the Boelgroep interns has also started to put the information about peatlands into cartoons and these kind of things. So keep an eye on our Facebook and website, and also on Repeat's website. It's also very pretty. If you want to stay into the subject and have like a bit of artsy stuff about it to make it a bit comprehensible also. So I just want to thank you all, and have a good evening.
Thank you so much. Bye, everyone.
Thanks. Bye-bye.
Bye.
Yeah, you did fine, Luis. Oh, hold on. Yeah, I think you did fine. Oh, we're still echoing.